let us start with the next topic, that is projectile motion. Okay, so what is projectile motion? You throw anything in space, the motion of that object would be a parabolic path, and that motion, whatever you project in air, the motion of that object is known as projectile motion. Okay, so this is very simple definition. Now, so there are some equations that we need to understand, okay, regarding the projectile motion, some terms, some equations. So see, suppose this is an object which is projected from this point, which is thrown in air from this point. I am not audible? Okay. Now you can you hear me? Okay. So let's suppose we throw an object in space from this point. So it covers this path. It moves along this path. Okay. And suppose it falls at this place. So this is a plain ground. Okay. And now see, you're throwing this object with some initial velocity. So u is the initial velocity, u bar is the initial velocity, and it makes some angle theta with the horizontal plane. Okay, so this u bar can be resolved along two components. One is ux, which will be equal to u cos theta, and uy will be equal to u sin theta, right? So when you go through the angle, that component is cos component. When you go away from angle, that component is sine component. Okay, through the angle cos component, away from angle sine component. After that, now this object is thrown, so it goes to this maximum height, and from there it comes back. Okay, we can say this is ascending motion, this is descending motion, right? So at this point, how much will be its velocity, or in what direction will be its velocity? Velocity is not zero actually. Velocity is in horizontal direction. Okay, you're throwing this object like this, its velocity at this point will be in horizontal direction. So we learned yesterday what will be the direction of velocity. So if you want velocity at this point, it will be along the tangent at this point. If you want velocity at this point, then it will be tangent to the path at this point. If you want velocity here, it will be tangent to the path here, right? So if you draw tangent to the path here, it comes in horizontal direction. Okay. So at this point, there is no vertical component of velocity. There is only horizontal component of velocity, right? And how much will be the magnitude of that horizontal component of velocity? It is same as that of the starting position. Why so? Because if you want to change the velocity, you will need some force, you will need some acceleration. Okay. So when you throw an object in air, there is only one force acting on it. At least we'll consider only one force. Okay, that is the gravitational force, which is acting downwards. Okay, which is acting in y direction, we can say downwards. Okay, so there will be no change in the x component of velocity, only y component will change. Fine. So x component remains constant throughout. Everywhere the x component of velocity will have same value. Okay, so then now, okay, so we can find out velocity, magnitude of velocity. U will be equal to what? Square root of ux square plus uy square. And what's the relation between this angle and x and y components of velocity? So we can just divide this y component with x component. So what will we get? We'll get tan of theta, right? If we know x and y component. If we divide y component with x component, we'll get tan of theta. Okay. So I can say, let me make it shorter. Alright, so I will write it here tan theta equals to uy upon ux. So if you want theta only, it will be tan inverse of uy divided by ux. So theta equals to tan inverse of uy upon ux, right? Okay. So after that, now we can apply the kinematic equations of motion for this motion. So this is motion in two dimensions, two directions, we can say. Okay. So we can break this motion along two directions. We can think of these two directions separately. So for motion along x-axis, what can we say? Final velocity will be equal to initial velocity. We have v equals to u plus at. There is no acceleration in x direction. So we can say the final velocity at any time will be equal to initial velocity in x direction. Okay. What about y direction? Now, if you think of the velocity from this point to this point in y direction, okay. So time is in between the starting and ending time. Okay. So Vy will be equal to what? Uy plus Ay times t, right? V equals to u plus at. And how much is Ay? So you are throwing the object upwards, okay? The vertical component of velocity is upwards and acceleration is downwards. So that's why, okay, Ay is equal to minus of g. So Vy equals to Uy minus gt. This is clear? This point. Okay. Then now see, after that what we can do is we can find out the displacement of this object, okay, using s equals to ut plus half at square, okay, in x direction and y direction. So see, for x direction, what we can say, for x direction, ux is equal to distance covered divided by t only, right? So it will be xt minus x naught divided by t, right? And x naught is equal to 0. We are considering x naught equals to 0. So the position at any later time, x position, it is x at time t, it will be equal to ux times t. And how much is ux? Ux is u cos theta, okay? So it is u cos theta multiplied by t, okay? And if you want t, so t will be equal to, I'm sorry. So if you want t, t will be equal to xt, okay, x position at time t, x upon u cos theta, we can say, okay. So this is for x direction, right? So we need to remember this, x at time t will be equal to ux into t. Okay? So t equals to x upon ux, right? Then for y direction, we want displacement in y direction. So for that, we can apply this equation. Okay, s is equal to ut plus half at square. A is minus g. So we get displacement in y direction equals to ui times t minus half of g into t square. And this displacement is final y position minus initial y position. So initial y position is 0. So we get final y position equals to u sine theta into t, okay, which is ui, u sine theta into t minus half of gt square, okay. So we get these two equations, right? One for x direction, one for y direction. And now if I put the value of time in this equation of in this equation, let's call it equation 4, okay, it's right. So in this equation, if I substitute this time, I will get the relation between what? Y and x. I will get relation between y position and x position. So that equation is known as equation of path of projectile. Okay, that equation is known as equation of path of projectile. So if you substitute that, time is equal to this thing xt divided by u cos theta. Okay, so here you have t, here you have t square. If you substitute that, you get yt is equal to tan theta times xt minus half of, okay, this factor g upon u square cos square theta multiplied by xt square, okay, or you can say y equals to tan theta times x minus half of, okay, x is x at time t, y is equal to tan theta times x minus half of g upon u square cos square theta multiplied by x square, okay. Is it clear till this point? Okay, so we need to remember this equation. We need to understand the initial setup, this equation, and this equation also, right? So after that, you have this y equals to tan of theta times x minus half of this factor multiplied by x square. So you put this thing is equal to alpha and this whole factor with the negative sign equals to beta. So you get this equation, okay, y equals to alpha into x plus beta into x square. And this is known as the equation of the path of projectile, okay, this one or this one. So this curve looks parabolic, right? So this is equation of a parabola, okay, this is equation of a parabola. Is it clear? Yes, no? Okay. So after that, now there can be a question. So question like this: suppose you are given with some equation, okay, you are given with some equation for path of the projectile, right? There will be some values here, and you want to find the range of projectile. Okay, so we'll discuss about that question afterwards. Okay. I'm sorry. Okay. Now, what we want to do is, given this thing, we want to find out the maximum height of the projectile. Okay, maximum height is maximum height. So it is the maximum distance which it covers along y direction, and the distance between start point and end point of this projectile motion. This is known as range. It is known as range and it is denoted by r. Okay, time for which it goes up, it is known as time of ascent. Then its downfall will start at this point. Okay, so time after that till this point when it reaches the ground, it is known as time of descent. Okay, so we need to remember the equation for maximum height, the equation for the range, equation for time of ascent and time of descent, and there is one more time, that is the total time for which it is in air. Okay, total time for which it is flying, it is known as time of flight. Okay, so see, now at maximum height the velocity will be equal to 0, and then using this equation v square equals to u square plus 2as, we can find out the displacement along y direction. Okay, and that maximum height comes out to be h equals to u square sine square theta divided by 2g. Okay, so we have to remember this formula: h is equal to u square sine square theta divided by 2g. So then, now can you guess for which angle this maximum height will be? Maximum height of the projectile. Height of the projectile motion will be maximum. This is the formula for the height attained in projectile motion: u square sine square theta divided by 2g. For which angle will it be maximum? Will it be 45 degrees? Think about this function. You have u square sine square theta. Yeah, it's 90 degrees because sine of 90 is 1. That's the maximum value of sine, right? Sine of 90 is 1. Okay, so sine square theta max to max, it will be equal to 1. Okay, so your projectile thrown with some initial speed u, it will attain maximum possible height when you throw it at an angle of 90 degrees with the horizontal. That means when you throw it vertically upwards. Okay, so this is simple, right? Then how much will be that maximum height? So it will be u square divided by 2g. Okay, so if you know this formula, you can find out that maximum height too. So actually, we had seen this. Okay, so when you throw something vertically up and it reaches height h, we had seen this, that how much will be the speed. So u will be equal to square root of 2gh. We have seen this formula. Yes, no? Motion in a straight line. Okay, when you throw something just vertically upwards, it is motion in a straight line. Okay, so h will be equal to what? Just square this. Okay, take 2g on other side. H is equal to u square upon 2g. This is the same formula. Okay, then let's come to the horizontal range. So how can we find horizontal range? So for that, what we do is we have this y equals to u sine theta into t minus half of gt square. Okay, so now initial position is 0, y is equal to 0, and final y position is also 0. If you substitute that, you can find out the time of flight, or how much time that projectile is in air. Okay, so that time comes out to be 2u sine theta divided by g. Okay, the time comes out to be 2u sine theta divided by g. And then we know distance covered in x direction. It is just equal to what? Ux multiplied by the time. Speed in x direction into time, because there is no acceleration. So you find out the distance covered in x direction, the range of projectile, it is equal to ux multiplied by t. Okay, and how much will be that t? It will be equal to the time for which it is in air. So that is time of flight. Okay, time of flight, right? All right, so if you substitute that, t is equal to 2u sine theta upon g. If you substitute that, you will get equation for the range of projectile, and that equation for the range of projectile is u square sine 2 theta upon g. Okay, so now u square sine 2 theta upon g, this is the range, and how much is height, the maximum height? It is u square sine square theta upon g. Okay, upon 2g, sorry, u square sine square theta upon 2g. So many times the students get confused between these two equations. Okay, so we have to remember them very clearly, because both of them have u square and g, u square in numerator, g in denominator. Okay, so for maximum height you have sine square in numerator, and for range you have u square sine 2 theta upon g. And maybe if you get confused, just recall how much will be maximum height when it is thrown upwards. You have u square divided by 2g. Okay, so formula which has 2g in the denominator, it is for height, right? Okay, so r is equal to u square sine 2 theta upon g. And now tell me when this thing will be maximum. This will be at 45 degrees, because okay, when 2 theta is 90 degrees, right? Sine can be at max 1. When 2 theta is 90 degrees, this term will be maximum. So the range will be maximum when you throw it at 45 degrees. Okay, so for maximum range, you have the angle of projection should be equal to 45 degrees. Okay, and yeah, so when you throw it at this angle, how much will be the height? So if you substitute that, Okay, if you substitute that in the formula of height, right? So u square sine square theta upon 2g. So you put theta equals to 45 degrees. Then we know sine theta is equal to how much? Uh, Sine of 45 degrees will be 1 upon root 2. So its square will be 1 by 2. So you get h is equal to u square upon 4g, right? This is 2g and this 2. So u square upon 4g. So R max is equal to u square upon g. H is equal to u square upon 4g. That means h is equal to R max divided by 4. Okay, h is equal to R max upon 4. Okay, is it clear? Is there any doubt till this point? Okay, is it going fast? Good. So then we found, I explained how to find the height of projectile, maximum height, the range of projectile, right? The time of flight, which is 2u sine theta upon g. So next is time of ascent and time of descent. For how much time it is going up and for how much time it goes down. Okay. So now time of ascent and time of descent, you can see it from symmetry also. It will be half of the time of flight, both of them. Okay. Time of ascent is u sine theta upon g. Time of descent is also u sine theta divided by g. Okay. Time of ascent is half of the time of flight. Time of descent is also half of the time of flight. Okay, so only there are these many formulae that we need to remember, and then there are few tricks, very simple tricks. Okay, so see this, we are projecting this projectile with initial velocity u bar, okay, which can be resolved along two axes, x and y. So it is ux times I cap plus ui times j cap, right? So initial velocity, I can say u bar is ux into I cap plus uy times j cap. Now, when this projectile hits the ground, you can see this angle and this angle will be equal. Okay, why will it be equal? Because the horizontal component of velocity remains constant throughout, it does not change. Okay, horizontal component remains constant. So ux and vx, they are same. Vx is equal to ux. What about the vertical component? So see, now when you throw something vertically upwards with some velocity, it goes to some height and it comes back with the same velocity. Okay. So if you think of y direction of motion only, then the velocity with which you throw it up comes back with the same velocity, right? So uy equals to vy, and therefore now what will happen? So see, it's projected like this, but it comes back like this horizontal at the beginning, okay, and it will fall with angle theta only to the horizontal. But now, okay, this theta will be negative. Okay, this is positive theta, right? It is in first quadrant. This theta is negative. It is in fourth quadrant. Yes, no? You understand this? You can. This is. You can say this is anti-clockwise theta. This is positive theta. It's anti-clockwise, and here you are going clockwise. Okay, with respect to horizontal, you are finding the angle. So this theta is negative. You are going clockwise. Okay, and then see what happens to the y component of velocity. Its magnitude remains constant, but its direction is opposite. Okay, its magnitude remains constant, but its direction is opposite. So now, if you know the equation, okay, if you know the equation of the velocity at start, okay, if you know u bar is equal to ux into I cap plus uy into j cap, or if you know ux and uy, what you can find out is final velocity. Final velocity will be what? It is vx into I cap plus Vy into j cap, okay, and that Vy will be in opposite direction, okay, it will be negative, so that's why I have substituted negative sign, okay, right? So then Vx will be equal to Ux, and what will be Vy? It will be equal to Ui only, okay, Vx is Ux, or we can put positive sign here, okay, and I can say that Vy will be equal to what? Minus of Ui, okay, so Vy equals to minus of Ui. So it comes out to be Ux into I cap minus Uy times j cap. So this is relation between the initial velocity and final velocity. Is this clear? Yes, no? Okay, Ganga, is it clear? So this is one important thing that you have to remember. And then suppose you have this equation. Yeah. Y is equal to, this is, let's suppose alpha times x plus beta times x square. Okay. So now what if I do, if I take alpha, okay, alpha divided by beta, if I take alpha upon beta, so it will be tan theta divided by, dividing by this factor is equal to multiplied by its reciprocal, right? So you have 2 times u cos of theta square upon g. This is in magnitude, okay, this is in magnitude, okay, I'm not taking this sign, negative sign. So then you have tan theta multiplied by this thing. So tan theta is sin theta upon cos of theta, and you have multiplied by 2 times u square cos square theta divided by g, okay. So then see, something gets cancelled out, this cos theta and this thing gets cancelled out, so you have 2 times u square sin theta cos of theta upon g, or you can say 2 sin theta cos theta, u square multiplied by 2 sin theta cos theta upon g, okay. So what is this? U square sine of 2 theta divided by g, okay. And what is this thing? Tell me, what is this formula for? This is range of projectile, right? Okay. So using this, we can find out the range of projectile. So if you are given the equation, some equation, and it is said that it is equation for path of projectile, how will you find out the range? So range is equal to this alpha divided by beta, okay. So it is magnitude of alpha upon beta, okay. So these are all the things that we need to remember in order to solve problems based upon projectile motion, okay. So now let us see some problems, okay. Help me solving the problems. Two bullets are fired horizontally and simultaneously towards each other from rooftops of two buildings 100-meter apart and of same height 200-meter with the same velocity 25 meters per second. When and where will the two bullets collide? This is the question. You are firing two bullets, Okay, two bullets and they are fired horizontally. This is one bullet, this is another bullet. They are fired horizontally like this. Okay, from two buildings which are 100-meter apart. So initial distance between them is 100 meters, right? So this is first building, suppose. The second building. Okay. And the height is 200 meters. So this height is given. This is 200 meters. Okay. Same velocity. And their initial velocity, which is in horizontal direction, it is also given. So u is equal to 25 meters per second for both of them. When and where will the two bullets collide? When will they collide? When will they collide? This is simple, right? Okay, forget about motion in y direction. Suppose there is no gravity, okay, and they are moving in x direction only. Because anyways, they have to cover this much x distance, right? So both bullets are reaching towards each other. You can call them A and B. This is suppose A, this is B, okay? And distance that A has to cover with respect to B is this much distance. How much is this distance? It is 100 meters, right? It's 100 meters. So can you find out in what time they will collide? Suppose instead of bullets, you have two cars, okay? They are moving with 25 meters per second towards each other and they are 100-meter apart. In what time will they collide? 4 seconds, right? Right, Ganga? Okay. So they will collide in 4 seconds. You can think of it like this: if there was only one bullet, okay, and distance is 100 meters, second car is at the other place only. So 100 divided by 25. Oh, you said 4 seconds? No, 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 it's not 4 seconds. It is 2 seconds. Right, it is 2 seconds. Right, 2 seconds. So they will collide in 2 seconds. Okay. So relative distance that A has to cover with respect to B is equal to relative velocity of A with respect to B multiplied by time. And if you want time, it will be SAB divided by that relative velocity. Okay. So, oh, so this is equal to, I can say SAB divided by UA minus UB, because they are in opposite direction. Okay. So this is equal to 100 divided by 50. So the time that you get is 2 seconds. So they collide at 2 seconds, right? 2 second, option A or option B. And then now how much y distance will they cover? So the distance covered in x direction will be equal. Okay. So they will move like this. Bullets move. First will move like this. Second one will move like this. Okay. And they will collide somewhere here, right? So we have to find how much of distance they will cover along y direction. So that, okay, so time is given. So how much is s? S will be equal to ut uy times t plus half of gt square. Okay, so that is uy times t So ui is 0 plus half of g is 10 multiplied by 2 square. So this is 4. 4 times 10 is 40. 40 divided by 2 is 20. Okay. So distance covered in y direction, this will be 20. Okay. This distance is 20. So at height of 180 or at height of 20, what is the answer? Option A. Right. So total height was 200. You have to subtract the distance covered in y direction. Okay. So the answer is option A. Good. This is clear. Okay. So this problem is simple, right? And it will not take, actually, it won't take any time. We were discussing this, okay, and I wanted answers from you. That's why it took some time. Okay. Anyways, next question. The maximum height of projectile is always 25% of maximum range. Okay, this is option. Sorry, this is assertion. Maximum height of projectile is always 25% of maximum range, and reason is, for maximum range, projectile should be projected at 90 degrees. So is it so? The maximum height of projectile, is it always, which option? Assertion is correct, but reason is incorrect. Okay, good. So for maximum range, projectile should be projected as 90 degree. This is incorrect. It should be projected at 45 degrees. Good. Okay. Next question. What is range of projectile thrown with velocity 98 meters per second with angle 30 degree from horizontal? So this is straightforward question, right? Just use the formula and find out the answer. So what is formula for range? U square sine 2 theta divided by g. Okay. So it is 98 square multiplied by sine of 2 theta. So sine of 60 degrees divided by g is 10. Or let's take 9.8 because here we have 98 square. Okay. So it will get cancelled out. So you have 98 multiplied by 98 upon 9.8 multiplied by sine of 60 is root 3 by 2. Okay. So 98 upon 9.8 is 10. 10 times 980 upon 2 multiplied by root 3. Right. 490 root 3. It's option A. Good. Okay. Next question. Assertion. When theta equals to 45 degrees or 135 degrees, the value of r remains the same. Only the sign changes. Reason. R is equal to u square sine 2 theta upon g. And options are, both assertion and reason are correct, and reason is correct explanation of assertion. Okay. So can you tell me, when theta equals to 45 degrees or 135 degrees, the value of r remains the same? Okay. Yes, both are correct. That is true. Okay, good. So see, you can explain it very simply. You have this horizontal ground. You project a projectile like this. Okay. This angle is suppose 45 degrees. And what will be 135? So this total angle is 180 degrees. If you subtract 45 from 180, you will get 135. So in the second case, your projectile is projected like this. Okay. The second case, the projectile is projected like this. Okay. So this angle, it is 135 degrees, right? This is 135 degrees, but how much is this angle? This is still 45 degrees. Okay. So the distance that it covers in this direction is range. Okay. So for this projectile, it will cover distance in this direction only, but the distance that it will cover will be same. It will be equal. Right. So does it matter in what direction you are throwing that projectile? Okay. For the distance, does it matter? You cover it in forward direction, backward direction, in this direction, that direction. Okay. Range will be equal if angle with which you are throwing it, if it is equal. Okay. So see, angle with which you are throwing. So here case is just you have drawn an axis. Okay, you are considering some axis, and with respect to this axis, this is 45 and this is 135. Okay, but actually if you look this side and throw it, with what angle are you throwing it? With what inclination are you throwing it? It is just 45 degrees. Yes, no. Okay. So both will be equal. Okay, and the see, this is assertion, this is reason. So both will be equal, and the range you will get from this formula only. So now, in order to check this, what we can do is we can substitute sine of, okay, this is sine of 2 theta, that is 2 sine theta cos theta. So for 45 degrees you will have some value. Okay, so 2 times sine of 45 multiplied by cos of 45, this is 1 upon root 2, and this is 1 upon root 2. Okay, and in case of 135 degrees, one will be positive and the other one will be negative. So sine is along y direction, it is positive. Cos is along x direction, it will be negative, right? So it is 2 times of sine of 135 degrees multiplied by cos of 135 degrees. So this will be 2 times of sine of 135 is equal to sine of 45. Okay, so this is the formula. Okay, you can tell this intuitively also. Sine of 180 minus theta is equal to sine of theta. Okay, then sine of 180 minus theta is equal to sine of theta. Is it true? Sine A cos B. This is sine of A cos of B. Yeah, minus cos is sine B. You can verify it. Okay, and sine of 180, sorry, cos of 180 minus theta is equal to minus cos of theta. Okay, so cos of sine of 135 will be sine of 45, and cos of 135 will be equal to minus of cos of 45. So this is 1 upon root 2. This is minus 1 upon root 2. Okay. So magnitude will be equal. The direction will be opposite. That's it. Right. So in this formula, u square and g are constant in both cases. Only this thing changes. Right. For first one, it is sine of 2 sine of 45 cos of 45. The second one, it will be 2 sine of 135 cos of 135. Okay, and here only you will have a negative sign. Apart from that, magnitude is equal. Okay, and therefore assertion and reason both are correct. Is it clear? Yes, no? Okay, or was it clear very earlier and I over explained it? Maybe that might be the case. Okay. So did I over explain it?